We've reached the end of yet another module and we've extended our knowledge on classes quite a bit. We looked at namespaces and we've learned that their main goal is grouping classes to avoid name conflicts. We've also seen static members. Making something static means that it's class level. Classes allow us to model real-life structures like an employee or a car, and on these classes we then add fields to store data and methods to add functionality. For real-life objects, relations exist between different types of structures, such as a manager being a specific type of employee or a truck being a specific type of car. This relation can also be applied on classes through the use of inheritance. In this module, we'll look at inheritance in C#. We'll learn how we can add this onto our classes and what are the benefits of doing so. Inheritance in C# is an important and very commonly used technique. Let us start with understanding the specifics of inheritance and why we should use it. Once we have understood the use case, we'll learn how we can add inheritance on our classes by creating a base class and a derived class. Next, we'll learn about polymorphism. I can already tell you that polymorphism is a very common interview question, so it's definitely something you'll need to get your head around. Once you have a good understanding of all this, we'll dive a bit deeper and learn about abstract and sealed classes. Finally, I will show you that everything in C# is an object, and it's really visible by looking at the base type for everything, system.object. A lot of interesting topics. Let's dive in. Let's kick off the module with understanding what inheritance is. And once we understand the concepts, we can apply it to our classes in the next topic. Let's return for a minute to our business case, where we have worked with employees. Let's for a minute think again of the real-life situation, not in C# code yet. It's a pretty broad term, right? If we look at Bethany's Pie Shop, all people working for the company, they're all employees and have a number of properties like a name. But employees will have a different role within the company. Although they're all still employees, some will be a store manager and will probably have a few specific functions. A few will be manager, there might be also a salesperson, and to figure out new pie flavors, we'll have a few researchers working for us as well. Because of their different role, they will have different tasks and perhaps as a company will also be storing different pieces of data for them. But they're all employees and they all have a name. And yes, they probably also share quite a bit of functionality. They all work for us, they all need to be paid, and so on. Do you hear where I'm going with this? What I'm introducing here is inheritance. All the different roles, so the manager, the salesperson, the researcher, and so on at Bethany's Pie Shop are all employees in the end. And we can also treat them as such. Because of this, they will share a lot of their functions as well. When we make the move to C#, inheritance is a very important concept when applying object orientation. What we will do is creating a class typically, and that will contain the base functionality. That will be, in our case, the employee class. Different other classes will inherit from this base, and because of this, they will share this functionality with the employee class. Indeed, managers are also employees, and many functions are the same. But probably not all. A manager needs to make decisions, needs to attend management meetings and the like. That is specific, and that will be part only of the manager's functionality. This tree, this inheritance tree, we will also model in our application. Inheritance works with parent and derived classes. The parent class or the base class is the one that contains the shared functionality, whereas the derived class or the child class will add specific functionality. You'll hear the term base class and parent class being used intermittently as they are really the same concept. In our case, the employee is the parent and the manager, researcher and salesperson will be modeled as derived classes. By default, when they inherit from the base class, they will share the functionality defined on the parent. One of the advantages that comes out of inheritance is that we will be able to reuse code. Instead of giving all the inherited classes the same functionality, we can now add it onto the base class and it can be reused from there. That is a huge win. That also means that if we need to make a change to common functionality, it has to be done only in one place. Our code therefore becomes easier to maintain. Another big win. I've so far mentioned the relation between employee and classes like manager, so parent and derived classes. but it can also be multiple levels deep. We could, for example, derive from the salesperson yet another clause, like junior salesperson, which is again more specific. Now that we understand the concept of inheritance, we can now apply this to our code, and I'm going to follow the example I've just laid out. I'm going to create a base class and a derived type in C#. This way, we'll understand how inheritance works in C#. Being an object-oriented language, C# fully supports. At the top, we have the base class, and as you can see, at least on the class declaration, there's nothing special going on. Then, the second one, the derived class, it's a bit different. It needs to point to its direct parent, and this we can do by adding behind the class name a colon and then the name of the base class. The colon and then the base class name are the way to create inheritance in C#. Now, doing this has quite a few consequences, as you'll come to understand. When we apply this on our business case, employee will be the base class, so we don't need to make any changes to that class at this point. Then we'll bring in another class, manager, and that will inherit from employee. It has a colon and then employee as its base type. Manager is now the derived class and employee is the base class. As said, introducing a base class has a number of consequences, which is pretty much why we would add inheritance, I think. The employee class will contain the functionality that all inherited types will gain because of inheriting from it. This means that the name field and the perform work method here, defined on employee, will become available for manager, as if they were part of manager directly. That is what you see here. Manager itself now contains a method called display manager data, which for now will just display the name of the manager. But notice that manager doesn't contain the name field. No, that is defined on employee, but we can use it on manager because we inherit from employee. Members defined on the base class will now become accessible for the derived class. Now, that last sentence does require some extra explanation. The derived class can access some members of the base class. This is where access modifiers start playing an important role. Remember the three most important modifiers: public and private, we've already looked at briefly, and there's that other one, protected. When using inheritance, the derived class can access the public members from the parent. No questions asked. However, members defined as private on the base class are not accessible. They are internal to the class and can't even be accessed by inheriting types. So if you want the derived class never to access a certain field, property or method, just make it private in the base class. Protected is somewhat in the middle. When using inheritance, protected members of the base class are accessible from the inheriting type. So for a derived class. So for a derived class, public and protected mean the same. They can access protected members just like they would access public members. However, protected members cannot be accessed from anywhere else. So for non-inheriting types, protected members are private. Let's see these access modifiers in action before we head back to Visual Studio. Notice now that I have made name private on the employee. To access the name protected again does allow the manager class to access it. Protected behaves like public for inheriting types. For anything else, it behaves like private, so the member will not be accessible. Alright, we've been talking for quite a while now about inheritance. Time to see it in action. Let's head back to Visual Studio and see how we can turn our employee into a base class. Then we'll create an inheriting class, and finally we'll learn about the access modifiers and what influence they have. So far we've used the employee type variable and the employee type property to distinguish between the different types an employee could be. And we used for that the employee type enumeration. But now in this demo, we are going to introduce, well, different types, different classes really, to represent the different types of employee, such as a manager, a salesperson, and so on. So I'm going to refactor my class first. Refactoring means, well, changing things a bit, so that I don't need that employee type variable anymore. That is going to give me some errors. As you can see here, I'm also going to have to remove the employee type here. And I'm also going to remove that here from the constructor. And finally, I'm going to also remove it here. There we go. I seem to be having another error indeed inside of the display employee details. I also need to remove this reference to the employee type property as well. There we go. Now, as you can see, Visual Studio now says that the employee type enumeration, well, isn't used anymore. So I can actually remove this and then things should compile fine. So now I'm at the point where I have my employee class and I'm going to represent different types of employees through different classes. And for that, I'm going to use inheritance. So inside of this HR folder, I'm going to add a new class. And that's going to be the manager. But in fact, the manager is very similar to an employee. A lot of the functionalities that we have defined so far, such as the hourly rate, the first name, but also the methods such as perform work, receive wage, stop working, well, they also apply for a manager. That is why I'm going to introduce inheritance here. I'm going to let the manager class inherit from the employee class. I'm going to do that by writing a colon and then the name of the base class. I'm also going to make this class public. There we go. As you can see, Visual Studio now does throw a small error here, saying that there is no argument given that corresponds to the required formal parameter first of employee.employee and then a couple of types. That's a bit of a confusing error, but if you look here, this actually points to the constructor indeed. What I need to do is I also need to provide in my manager type a constructor that will then pass data to the base constructor. Because I can in fact not create a manager without there being an employee really, because every manager is in fact an employee. So I'm going to introduce a constructor here, and we do that as we did before. It's going to consist out of the access modifier public and the name of the class. I'm also going to be passing in a couple of parameters. Let me add those first. And let's introduce again, of course, curly braces. As you can see, there's still an error that is again saying pretty much the same. It is still saying we need to create that employee before we have that manager. So I need to in fact invoke the base constructor, and that's going to happen through the base keyword. The base keyword allows me to, well, call the base constructor, passing in values that are now passed in for the manager to the base type. So I can now in fact here say call the base constructor to the one on employee, passing in the value first, so that's this one, and I'm going to pass that to the base, so the employee constructor. I'm going to do the same for last, I'm going to do the same for EM, I'm going to do the same for BD, the birthday that was, and I'm also going to be passing in a rate. And now Visual Studio is happy, as you can see. It's now accepting my change. So what I've now basically done through introducing the base keyword is calling the constructor on the base class, so on the employee, passing in the values passed in for my manager creation. At this point, my manager class exists, and because of the fact that it inherits from employee, I can do a lot of things already with it. Let's go and give it a try. We can of course create still an employee as we did before. And that is what we see here. So I'm creating a new employee, again, Bethany. But I can now, in a very similar way, create a new manager. That is my new type. And let's call that manager Mary. And I'm going to now simply create a new manager object by calling the manager constructor. And that accepts, well, pretty much the same parameters. So I need to pass values for these. So there we go. We have now created a new manager object, a new manager instance, and we named that object Mary. Now on our original employee type, we can do what we did before. We can display the employee details, we can ask our Bethany object to perform work, and we can also call the receive wage method on it. But now, since every manager is in fact an employee, I can also on that manager, on the Mary object that is, invoke, for example, the display employee details. And this will, of course, if I now do a go to definition on this, show me, well, the same display employee details, as you can see here, in the employee class. So this method is now available, is now known, let's say, on the manager class as well. And of course, in a very similar way, we can also ask to perform work, we can also invoke the receive wage method. And if you run this, well, we see that Bethany has performed some work, and then we see the details for Mary, Mary has done some work, and now Mary receives a wage. Now you may be thinking at this point, well, that's fine, but what is the added value? Mary can do the exact same things as Bethany, our employee. So the manager is not really different from the employee at this point. Correct, but I can now of course extend my manager type. I can add things here on the manager class that are not available on the employee. What does a manager do? Well, for example, an added functionality wrapped inside of a method that is attending a management meeting. So it could be that our manager needs to perform an action that is not available for an employee, such as attending a management meeting. Management meetings tend to run very long, so I'm going to increase the number of hours worked with 10. Now by doing that, I've introduced something that you may not have noticed yet. The number of hours worked is now used within the manager type, but it was also available on the base class, so on the employee. And because this is public in the employee class, I can directly work with this in the manager type as well, as if it were defined on the manager itself. And let us add some console output here to display that our manager is attending the management meeting. And I'm doing pretty much the same thing here for first name and last name. Those two are the ones defined on the base employee class. Now I can go back to the program class and I can actually let our manager, so Mary, attend a management meeting. That is now a functionality available only for managers. Indeed, I cannot ask Bethany to attend a management meeting. As you can see here, Visual Studio is complaining and says, well, employee does not know about attend management meetings. Indeed, that's only available on the derived type, so on the manager type. Let me return once more to the manager, and let's talk a bit more about access modifiers. In here, I could directly access the number of hours worked. That's a public property, and I can work with that from my derived type. On the employee, I also have first name and last name and email and the number of hours worked, so the private field. I can, in the derived type, not access these private fields. So if I want to access the number of hours worked, I cannot. As you can see, I can access the property, but not the private variable. Indeed, any private variable I create here on the base type is available only within the base type. Derived types cannot access those. They can only access public as well as protected ones. Let's work with protected for a second. Let us now say that I want to allow derived types to access the number of hours worked for a variable. I can do that by making it protected. This will make this one available for derived types, but only for derived types. From the outside, I can still not access that. Let me show you this. I can now access the number of hours worked, and I can set that also to +10. And this is now accepted. That is now a protected field, and that's available in the derived classes. So protected means available in the derived type. But still, from the program class, I cannot access it. If I now go to my Bethany type again, and I want to access the number of hours worked, you see I only get the one with the capital, so that's a public property. The protected data is still not accessible. I've now set my number of hours worked back to private, because I can work through the property in my derived types. Using these access modifiers also applies on methods. Say that I want the stop working not to be available on derived types, well then I could make this private, which would be quite weird, I know. But let's say that I now want to, from the manager type, access the stop working method. I will not be able to access that anymore, because it's private. And Visual Studio will say that here as well. It is inaccessible due to its protection level. If I make it public or protected, then it's available again on my derived type. And let's set this back to public. What inheritance in C# is bringing is what is sometimes referred to as the is-a relation. Indeed, even in the spoken word, you would say a manager is an employee. The is-a relation is exactly what inheritance is bringing us, also in the behavior we're getting in our C# code. When we define a manager instance, where the manager class derives from employee, all public or protected members defined on the base employee class become available for manager. If perform work is a public or protected method on the employee class, because manager is an employee, it becomes available for the manager. The manager class can, like we have seen in the demo, of course add new functionality, which is then only available for manager instances, not for employee instances. And of course, Multiple types can inherit from the base employee class. If researcher 2 inherits from the base employee class, every researcher 2 is an employee, and therefore researcher instances will get access to perform work as well. Let us return to Visual Studio and work with multiple classes that will inherit from the employee base class. Because they inherit, we can use the is-a relation and get access to that base functionality. I've now gone ahead and added a few extra types here. Let me show you. I've now added the developer type, which is a very simple one. It's also deriving directly from employee. I've also added the store manager. Again, the same thing. This shows that we can actually have multiple classes that derive from the same base class employee. But we can actually go a bit further. Let me add one more. I'm going to bring in the researcher class. Is my researcher class, which adds the ability to research new pie tastes. I like that idea. Anyway, what this is going to do is going to accept the number of hours put in research and it's going to add that to the number of hours worked. So in that view, it is still pretty similar to what we had with the manager. We added a new functionality, a new method on the derived type researcher. Now we can, with inheritance, go multiple levels deep. For example, I can introduce another class, the junior researcher, which does not directly inherit from employee, but it inherits from the derived researcher type. So now I have junior researcher, which inherits from researcher, and researcher in turn inherits from employee. So we can definitely go multiple levels deep. And we can use the junior researcher, well, in a very similar way. Let's go back to the program class, and I'm going to introduce another object here. I'm going to call that Bob Jr., and that's our junior researcher. I initialize that again through its constructor, as you can see here. Because of the fact that Bob Jr. is a junior researcher, I can ask him to research new pie tastes. And that was a method that accepts a parameter of type int, so I can ask him to put 10 hours in research work. And because Bob Jr. is an employee, he can receive a wage just like an employee. Indeed, public and protected members cascade through the hierarchy. It's not stopping at the first level of inheritance. Let's run the application to see that everything works fine. And there we go. Here we now see that Bob has invented a new pie taste. He has worked for 10 hours on that and receives a wage because of the call to receive wage. Now that we have a good understanding of inheritance in C#, let's look at polymorphism, another important pillar of object orientation. We now have created a few classes and applied inheritance. I think it's clear that using inheritance we can reuse code. Functionality defined on the base type, like you see here with the perform work method, is accessible from the inheriting types, and that allows us to move common functionality to the base class. Thanks to inheritance, we can create a manager and call the perform work onto it, defined on the base employee class. Similarly, we can create a researcher and also call the perform work on that. Now, although this is great, the invoked method will always be the same one for all inheriting types. Now you may be thinking, wasn't that the goal of this all? Well, yes, of course, but what if we want to have a modified version of perform work for perhaps a few inheriting types? This is where polymorphism comes in. Polymorphism will allow us in C# to provide a different implementation by an inheriting class for a given method. The name polymorphism indeed says poly, which is multiple, and morph, which is form. We can give a different form to a method in the inheritance tree. Polymorphism is tightly linked with inheritance. Instead of just using the base class method, we can, in an inheriting class, define a new implementation. The base class would actually indicate that an inheriting type can, the implementation of perform work might be different than the generalized one that we wrote earlier on the employee class. What we should do now is recognize this in the employee declaration. We should say, well, here's an implementation that all inheriting types can use, but you can provide a different one for inheriting types. This we do by